Hello folks, in this video tutorial I want to show you a strategy which allows you to solve the problem that was posed in tutorial 3, and the strategy that I'm going to be using in order to solve that is called the impose point strategy. There are several other ways of doing this problem that will appear in the next few tutorials that I'm going to prepare. The problem to be considered is a beam problem. It's a frame problem, as you see here. And the dimensions of the dimension of the cross section, dimension of the cross section, and material properties are going to be given at the end. That's not important right now. And there is a point here. This frame actually is a two-dimensional frame, but I'm going to pretend I'm not going to make a sketch out of that. I'm going to make this thing as a wireframe, so a line in space like that, and a line in space like that, etc. And the ends are clamped, and a point is subjected to 1,000 pound, as you can see here. Tutorial uh, in tutorial 3, I showed you that if this load happens to be right up there at that juncture, uh, things are a little bit easier. However, on purpose, I'm going to put the point exactly halfway between these two locations. Now, this problem is also related to what was discussed in tutorial number 2, where the issue of imposed point was brought up. So I'm not going to go through the details of what I did in tutorial 2. Instead, I'm going to solve it the way you're supposed to with the strategy. And if you want, you can go and watch tutorial 2 later. So the model that's going to be made is actually like so. So this is the idealization of this problem. And because we're going to be putting a load right at this juncture point, I'm going to create a point right there. Okay. And later on, when it comes to meshing, I will make sure that this point is included in the mesh. Don't forget, you have to join this structure anyways, because uh, well, first of all, the advantage of joining the structure is that when you join this line and that line, when you mesh it, both of them are going to mesh at the same time. Also, if you don't join it and you try to do the problem, for example, there's going to be duplicate nodes at this juncture. If this is not joined, so there's going to be, you have to join these lines separately when you mesh this thing, unless you ask for the the nodes which are close to each other to within some tolerance to be captured, there may be duplicate nodes here. So that's what I'm going to do. I'm going to make sure that this is joined. The important point here is to show you how to include a point in your mesh so that you can actually put a load on. Okay. Now here's the material properties, and let's go make the model. Let me remind you how to display the cross section if you ever want to, and change the size of the different things when you're using beam elements. Okay, so let's go out here. Because I'm going to be using join, so at some point I have to go to the generative shape design. So I have a choice of starting in part design, creating my wireframe, and then later on I have to go to generative shape design to join it. But that's it. And since that's the case, I might as well start with generative shape design. So I'm going to click on that. Sweet. There we are. And I'm going to create a wireframe in space. So let's go to wireframe. I'm going to make 2 lines. And the method of making the first line vertical line is point and direction. Point and direction. I'm going to create the point, and the point is going to be right there, 0, 0, 0. And the direction is going to be direction Z. And it's going to be 10 inches long. Right there we are. And then another point and direction line with point and direction. The point is going to be right there. And the direction, since it's at 45 degrees, I'm going to put the cursor there and right click, and it says, no, sorry, not there, over here, click, put the cursor there. left click and edit component. That means we're going to specify the direction. I'm going to make it 1 and 1 in the Y and Z direction because that'll give you a 45-degree angle. And then the length is 10. It's already good. 10, we say okay. All right, so that has been created. Then I'm going to create a material for that. So let's go to the cross section. The cross section is circular. Therefore, I don't need an orientation point. Otherwise, you need an orientation point so that I properly rotate the cross section to align what you want. But since it's a circle, it doesn't matter. So we go to tools, and here create a material. And I'm going to call this thing impose strategy. Impose strategy video. And all it is steel properties. Video, we say okay. It's going to be created in my database, but I haven't inputted any numbers yet. So let's see now. Let me see for a second. Import strategy right there. So I'm going to take this thing and put it there. Green check mark. And we have it here. So let me go and put in my numbers. Double click. So it's going to be structural, abacus multiphysics, mechanical, elasticity, elastic, 29,000 KSI, property of steel. KSI, Poisson ratio, I don't need it, but I'll put down 0.3 anyways. And then we say, okay, good. All right, so now we're going to go and join this. So let me go back to shape design right there. On the transform, join these two lines. All right, and I need to create a point here because later on it has to be included, okay? But let me not do that right now. Okay, let me not do that right now. Let me just leave it the way it is, okay? So we're gonna go to structural model creation, empty FEA model. Click on the mesh. Here is the beam measure. You select it. Notice that I did not I did join it right there. And mesh size 1, and it's a linear element, mesh size 1 inch, consistent with what I put down here. Okay. Size 1, linear beam elements. Now, what I would like to do, I would like to see that impose point. I want to impose a point that I have not created yet. And I'm going to try to do that, but let's see what happens. You click on this. It says, okay, where is that point? Where is that point? Where's the support? Since I've not created a point here, let me go and try to create it. Left, it says select the support. Now I did not create a point here, right? I did not create a point here to begin with, but I can do that. Put the cursor there, left click, create a support, create a point. It says select the parent of the created feature. Well, it's going to be this joint, right? It's going to be the joint. And there are different ways you can put the coordinates here. For example, you can say 0, 5, 0. Or you can do other methods, for example, create on the line, etc. Oh, create a point by putting coordinate here. So height of 5, 0, 5, 0, 0, 5. That's what I meant. You say okay. Notice that a point has been created here, and then I say okay. But when I do that, it's going to come up, it says support is missing. So let's see, I tried, say okay. See, I created a point there, right? So let's try it. When I try to select this, it wouldn't take it. That's a problem that I discussed in tutorial 2. There is a problem there, okay? So the solution, the way around that, will say, okay, let me cancel that. Let me get out of all of this. Get out of all of this, okay? What I'm going to do is, and I don't know whether you want to call this thing a bug or there must be a reason this is happening. I'm going to create any line, any geometrical shape, such as a box, a surface, a line, somewhere in this part. So let me go back to a 3D shape. On this horizontal plane, sketch, just a line. It has no significance, but just a line, and exit. And let's go and now try to do the same thing. So we go back to the nodes and elements, B measure, select the joint, okay, 1 inch size, linear, and now we try to do the impulse point. Click on the impulse point. Now create the point. I'm repeating the steps. The only thing that has happened is that line that I drew at the bottom. Create a point. Select the parent. I'm going to select the joint. It was 005. And then say OK. You see? Now it's picking it. So the presence of this line here, or this other geometrical feature, I mean, I could have done a box, or I could have done a cylinder, so make something, okay? And then I say OK. And then mesh. And then OK. So if you zoom in, you will see that actually there is a node right there. You can see that. Now, without this line, it will not let me do this. And this was the essence of tutorial number 2. Okay? All right. So let me, in fact, if I don't want this thing, I can delete it. Or I can leave it. It really doesn't matter. So it's up to you whether you want to leave this line here. It's not going to do me any good or any harm. Or you can go and delete it or deactivate it, whatever. Yeah, I'll just leave it the way it is. Okay, let's go to the rest of the problem. So we go to abstraction, not abstraction, sorry, properties. Let's create a circular profile, beam profile, circle, radius 0.5. And then say OK. All right. And now create a beam section. Profile, the support is that joint. And the profile is that beam profile 1. And then we say OK. We can close this thing because it's a circle. Doesn't require an orientation point. Now, if you want to see your elements, so you go visibility manager. Don't show me the part. Show me the element. Notice that this line here doesn't participate. These are the elements. You can see that. And there's a node right there. Okay. Impose point. And the trick was to draw that thingy here. I mean, as I said, this doesn't do anything. It's just that. Okay, let's do the rest of the problem. So now that we have done this thing, we're going to go to structural scenario creation. We use the model that we created, finite element model that we created. Okay. And the procedure, we're going to make it very straightforward static perturbation. That means a static, basically. No nonlinearities. Say OK. Let's clamp these ends. Okay, so we go to boundary condition. There's a clamp, one here and one there. And apply a force on the loads. Apply a force. Now we can select this point. You see that? We can select it. And in the y direction, say OK. And that's it. I strongly suggest that you look at tutorial number 2, which is talking about issues with impulse point. I will repeat this problem in the next few tutorials using other strategies. So let's go ahead and on the simulation tab, first of all, do a model and scenario check. I don't anticipate any problems. Okay, good. And the simulation check. Once again, I don't anticipate any problem. made a difference here is that extra geometrical feature, the line that I created, I didn't use it. It's just that without that, it would not allow me to basically include that point that I created in my finite element model. So this is fine. And then once I get the close box here, I close it and then simulate. Okay, good, close. And now we're gonna run it. The whole issue was that extra geometrical feature that I had to create. And in tutorial 2, I show you just creating a point out there is not going to do it. But when you do a line or a box or a cylinder or a surface, etc., it'll allow you to proceed. It's complete mystery to me. My only guess is that it could be a bug. There are other ways to resolve this issue without using that impose point condition, and I'll do that in future videos. This is pretty much all done. Close that. And there we go. Okay. This is the Varmisa stress. You look at the displacement. And you can animate it. Remember, you clamp here, and apply load there. Of course, it's going to behave like that. Okay. That's pretty much it. Good luck.